Yes, this is 20 points. If anybody wants to read before I start the recording, just Flores, she raised her hand fast. Go ahead. Thank you. That was 20 points here. Thanks for reading class. Get your attention. We're talking about this problem here. The end problem is called actually catch me if you can. So you can look at the problem and how to do it, but I'm going to demonstrate this because the book always doesn't show you stuff. So I have to show you the in-between steps like algebra. Also, some of y'all investigate grades because you're not showing the algebraic steps. In science and engineering, you have to prove your work. If someone else reads your stuff, they have to be able to replicate what you did. So you can't do shoddy work and expect a good grade. All right, first things first, let's open up this ancient technology called a book, everybody. And we want to go to, for your first part of your notes, page 58. Everybody see that box right there? It says, position time equation of motion. Please type everything in that box to start your notes off in the weekend. You don't still open the computer up? Go. No, I'm saying try to use it. There's a water bottle on the ground that goes right to the desk. Open it up, there should be a password. Oh, that's why. Hey, everybody else, give me a second. Get that typed up because I'm going to move through this fast as I can. A lot of steps. But you need that as your tool to navigate you through this problem. That's what I'm going to talk about first. About that one here. I got to fix this up. Okay, so what are we working with, right? Again, while y'all writing that down, let me talk about how it's dimensionally measured, because that's how you can pick this problem apart. If you don't know what the variables mean, then you're going to have a hard time, right? So the name of this again is the position time, right? X and Y axis, equation of motion, okay? I guess the temperature's rising, so I'm getting hot in this suit. So what do we do, right? Well, let's write the equation out. Remember a long time ago I told you about XF, right? So XF is equivalent to XI plus velocity, right? And it's multiplied by time. Rush, can you get him or Dale? You can't go to the cart, my man. Just have a seat when you can, right? Velocity multiplied by time. You don't like that one either? Jeez. Rush, you gotta use some of these over here. Yeah, use these. Yeah, the school keep coming to my classroom taking it. Just leave it there for a second, I'll get it. All right, so we have, when you talk about positions, these are both measured in terms of meters. This is how you can tell, what you're using or what you need to take from the problem and your greetings together to solve it. For velocity, it's a ratio that's known as meters per second, and time itself is just a dimension of seconds always, right? So now we can dimensionally put together. If your dimensions don't, there's my lab assistant. Lauren caught one off later soon. She is, you a whole lot. That is one of the LAs. So I'm glad you're here. You can help people get on track. We got a lot of latecomers. You just gotta walk around and see if you got the right. All right, so we'll box this off. This is all covered on what page again? Who remembers? The box? Huh? Okay, I need you to raise your hand. You're right, 10 points. Let's see if I catch somebody off guard. This is number 1 of your notes, by the way, too. So structure your notes like they should. Water bottle on the ground, please. Next, we have note in our notes. This is number 2 of your notes. And please put down all notes. I'm up here doing this problem. I need you to do your part and type every step so your work makes sense. Stop cutting corners. All right, what do we have? Let's go to page 61 of the physics text. And you'll see that, just briefly, you have 2 lines that intersect. This is what we're doing mathematically. It shows you on this page how it graphically is represented. and why you're doing the math, right? So let's break it down. We got two situations. We have you, what you're doing on the walkway. If y'all travel to O'Hare or Midway Airport, there's something that looks like an escalator, but it's flat. It's called a walkway. You walk on it, it takes you to your destination where you don't have to walk too much. So this is the situation, right? Known values. Let's talk about you, for instance, or just to start off with you. These are the values for you, so please put that. And we know that you not only on a walkway, you have a rest, which is, in physics, means 0 meters. So we're going to say initial position, xi, is equal to 0 meters. Okay? What else do we got? Well, once you get on there, of course, there's a speed, isn't it? And that's the velocity. So let's look at the problem carefully. It says up there, and the problem's up there, I'm talking about, yours is on your page. So when we talk about you, we got to take our time and read it, right? So it says, at the moment, you, right? Take your time, because you have a you do problem like this, you got to read it correctly. At the moment, you, right, step onto the walkway, right? It tells you about your friend. But then it says your speed, because some students are messing this up. You come down another, after you read that, careful, it tells you you are actually going 4.44 meters per second. So velocity of you is 4.44 meters per second. Another place where people are getting messed up with their points is put your dimensions. If you just put that down as 4.44, I'm a scientist, I'm like, what's that, apples, oranges? What are you talking about? Put your dimensions in. All right, when we talk about the next thing, we got to talk about your friend. So we're flipping the perspective, right? When we talk about your friend, it's his initial or her, depending upon if it's a male or female friend. And yes, before somebody asks me, do I got to put that? Yes, you do. I will take a picture. Please put it so you get full credit. Stop trying to finesse me. All right, so XI, right? Well, the initial position of your friend is 8.9 meters. This is, again, taking the problem slowly apart. So XI, right, is 8.9 meters. Well, how fast is he going or she going? We look at our problem again, take our time. They say, you know, that they, I was like, who is that? It's Knox. I'm sorry, McNeese. Thank you. And if you can get it caught up, McNeese, it'll be appreciated. So their speed is 2.56, right? So let's go here. That's 2.5, write this correctly, 6, and that's meters per second. Again, that's why we did this part. Or I did this part. All right, so after we get those values, we got to find out a time, if we're looking at that graph, where they intersect each other or catch up. So that will be time, lowercase t for the last time, of 4.53 seconds. So I'm going to write that down. These are your ingredients to get this problem done. And you need all of them. All right, unknown values. You got two of them. So let's consider part A and part B. You got to find out the final position, XF of yourself on that walkway, and then of your friend when y'all finally come to each other, right? You finally catch up to each other. So to do that, we're going to put this down as final position, XF, is equal to some number in meters. We're going to calculate in a moment. And this is for you, right? So we're going to do you first. And then we got to flip the perspective, and let's just call this part A, ladies and gentlemen, and part B. And what we're working with here is, again, some number we're going to calculate using our tool here, all right, our position time equation. And this will be considered all of your part 2 notes. Now, let's finish this off. And how am I doing on time? 20 minutes, it's not bad. So, next steps. We're going to call this part 3 of your notes. So put your stuff in order when you're typing it up. It's another thing people are not doing. They're just typing stuff up. There's no statements. There's no explanation. Again, somebody else needs to look at your work with the staff, or anybody that doesn't have any type of STEM experience. They should be able to replicate what you saw. Anyway, number 3. We're going to say, hey, for part A, and please write this down or type it down, we're going to solve, because you're explaining your thought process here, for XF, final position. Okay. To do so, we're going to take our trusty mathematical tool here, known as a kinematic equation, and we're going to set it on our operating table, right? So let's use it. XF is equivalent to XI plus your velocity multiplied by the elapsed time. Let's write that again. For those that typed it, you can just copy paste the line down. But instead, we're going to plug in our values. Now this situation, I should have wrote that, is for you, so you know which values to use. The time itself is used for both situations. It's kind of like a paradox or a relativistic point. Talk about that later at lunch GGI. I'm sorry, at game room if you want to know more. So you started off with rest, that's 0 meters, all right? Plus, just plug in what you got here. Your velocity, or how fast you was going, initially was 4.4 on the walkway, meters per second. Of course, you use this time for both situations. So we're gonna say multiplied by your time factor of 4.53, and that's seconds. Now, everybody's favorite part, because we plugged it in, right? We calculate. You use Google, the calculators on your desk, they're engineering based. So has anybody had it before I punch it in? You get 10 additional points if you're keeping up with it. So I'm going to type it in. I'm going to give you 30 seconds, somebody to get these 10 points. Because I'm about to calculate it. 4.53. No takers? Nobody's doing it? Okay. Well, 20.11. And who can tell me what is measured in? For 5 points. What is it measured in? Meters. Yeah, that's why you want to move out the way. Get 5 points. You tried to say it. You was like, can you move out the way? I did that on purpose, Miss Woods. I was trying to see if you were listening or paying attention. She looked at the board and found it, y'all. That's why I did this up here, right? All right, so, and then also your known values. So we're gonna box our answer for y'all that don't, are typing, just bold your answer, or you could, some students are even putting in yellow their final answers. That means they're doing it cleanly and correctly. We're done with that part. Part B is our final part, and then you have the rest of the period. If you run out of time, you got homework. I know this generation don't like homework, but that's what happens. And you can borrow a physics book to do your exit slip questions if need be. All right, so part 4 of your notes, we're keeping them together. We're doing the same thing, but for your friend. So let's go ahead and write out what we're gonna do. We're just gonna state our case. So the reader of your work knows what you're doing. You're gonna say part B. I'm gonna solve, right there cleanly, for XF, yet again, but this time for your friend. I think I almost ran out of room there. Okay, that's for your friend. So, I'm messing up. I'm rushing. Look at the time. This is XF, y'all. All right, so let's take the same tool, kinematic equation, and put it on our operating table. We have XF is equal to XI plus V times T. We are now going to plug it in and be done with this. So the initial position for your friend, because they had to start, was 8.9 meters. Plus, velocity of your friend was now 2.56, a fraction or so slower than you were going. That's pretty much why they can catch up. Multiply by the same time elapsed, which is 4.53. And seconds will cancel out. That's why we got meters. I wanted y'all to see that. XF is equal to, let's get our trusty engineering calculator. Y'all can also do this in Google. All right, just hit equal sign, Google turns to a calculator. Use your tools correctly. So, turn it on, and I'm gonna carefully make sure I follow my rules of engagement. 8.9 plus 2.56 times, we have 4.53. You get a yield of 20.49, right? And again, who can tell me what this is measured in for 5 points? Oh, everybody's trying to get the point. So I think I've seen you, and you. So 555. Again, dimensions matter. Some students are really mad at their grade. Look, if you don't put these dimensions down, I know it sounds petty and tedious, then I can't give you credit. Just think about this. If you didn't use dimensions correctly and you're an engineer, especially like a civil engineer, that building would fall down and then you got a lawsuit. So please do it the way I'm trying to show you. That's 20.49 meters. Box my answer. And that's all she wrote. The rest of the class period, you should be working on your you-do questions and your exit slip. Exit slip questions are straight from the book. You have, I think, one you-do just like this. If you did it in a we-do, And you can take the numbers, change them, recalculate, you're done. Don't make this stuff hard. You also got Miss McNeese here, who's in LA. She can help you get this done too. She's done it several times. Points go to, I forgot. Was it you? Yeah, you was the one that said, let me get that, right? It's 45 points. You need